Assalamu alaikum warahmatullahi wabarakatuh. Friends, when we see some circuits, we find this type of components which is called resistor. Different type of resistors. These resistors are called power resistors. These are used to control a current in any power circuit. We use different types of resistors. Every resistor it have a power rating and ohmic value and its tolerance temperature coefficient. Today we will discuss two parameters. What is the relation of resistance and power, because it is used to control a certain amount of current. When a current flows from any material, it dissipates power, because due to ohmic value I square R formula, we can see we have different values. This is mounted on heat sink. It is used for more current. This is 15R 0R. It means 15.0 ohm resistor, but 10 watt. 15 ohm, 10 watt. We will discuss these two items, 15 ohm, 10 watt. We will see in detail when we have a ohmic value, when we have a wattage, we must know the current. Another resistor, we can see the first one is 15 ohm, 10 watt. The second one is 6.8 ohm, 7 watt. This one is 2.7 kilo ohm, 3 watt. 3 watt. Now we will see the values of resistors and the power dissipation. These two parameters depend upon our requirement. Where I have to select the resistor. This is 2.7 kilo ohm, but it is 3 watt. Red lead at ohm, black lead at common. This one is 6.8 ohm. 6.8 ohm. Now it is stable, 6.8 ohm. It is a fixed value. These resistors are used in power supplies. This is 1 ohm, 30 watt. 1 ohm, 30 watt. Why these are different values, we will see now. Because when we have to select a resistor, we must know the amount of current. Amount of current can be known by the power over R whole under root. This formula is used to determine the amount of current from a resistor. And now we will discuss how to select a resistor. If we have a circuit, we have to select a resistor value. First, I will go from reverse. I have 10 watt, 15 ohm. It is, when I will calculate it, it is 816 milliampere. Okay. P is equal to I square R. I will cross verify. I is equal to amount of current. I is determined as current, amount of current. 0.816 square, I will write 2 times. Then value of resistance, that is 15 ohm. Yes, I will write 15. It is around about 9.998, 10 watt. Because I take first 3 digits from 860 milliampere, so it is very close to this. So if any circuit which is delivering 816 milliampere current maximum, I have to select a resistor value 15 ohm, but I have to select 10 watt. I think it is now clear. If any circuit that is discharging 816 milliampere maximum current and I have to use 15 ohm resistance, then I have to select the parameter watt for 10 watt. All values we can determine by this formula. Now I will check the voltage. R, I know the value of R resistance, that is 15 ohm. Current we know 16 milliampere, 0.816 ampere. Now we can know the voltage V is equal to I into R, ohms law. We know the current 816 milliampere or 8.816 ampere, and we know the value of resistance. So now it will about 12 we will multiply 0.816 multiplied by 15 and we will check the value of voltage. 12.24. Now friends, if I have a power supply circuit where I have to use a series resistance for any purpose, this circuit can discharge 816 milliampere or 0.816 ampere. So I must have to select a resistor value 15 watt. This is a circuit block diagram, any circuit, any type of circuit which is giving approximately, you can say, 12 volt. It's idea, okay, and 0.81 ampere. How much will the maximum total load resistance or series resistance R value? That is 15 ohm maximum and 10 watt. Now we know the two parameters. The first one is voltage, the second one is current. If we know the amount of voltage, if we design a circuit where we know the value of voltage and we know the amount of current, I is equal to 0.816 ampere, we can select the value of resistance. R, value of resistance, will V over I, this formula. Now we can determine the amount of resistance, that is 15 ohm. We can select any amount of resistance, wattage. Now we can find power dissipation, how much will I square R. So we can find a value of resistance. Now the next parameter, when you are designing a circuit, you have to select the geometry of a resistor, because there are many types of resistors. Some are PCB mounted, it is used in PCB. Here we can select value of resistance, wattage by these two formulas. Resistance from this formula, if we know the value of voltage and current. When we know the value of current, we can use resistance and wattage. And the next is our geometry, where we have to install. If I have to install on PCB, yes, if I have to use on PCB, I will use PCB. If I have to use on a chassis or a heatsink with screws for more cooling, so I have to select this one, metal case, metal body resistance. Okay, if I have a PCB, I have to use this one, like this. It will be installed on PCB. Okay, this one is installed in PCB and it is from some height, and if I will use at a chassis or body of any assembly, I have to select this one. Thank you for watching this video. Bye bye.